Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. And in the previous lecture, we looked at the person class that we created. And we saw that this person class has a nested inner class book, which had a native method, which is not a static method. It's an instance method. And we implemented this in C++, and we were able to call this. And then we also had this static nested inner class bag, which had an instance method print size, and also a static method print size, which takes an argument of type bag. All right, so the parameter is bag, or we can also say person.bag. It doesn't matter, because as long as we are within the scope of this class, we don't need to use person.bag. We can just use bag itself. All right, but it's equivalent to saying person.bag. And we said that this print size is overloaded, and we said that the signature in when we are dealing with the inner classes, the $sign in C++ signature is always replaced by _00024, so 3 zeros and 24. And in this case, because this method is overloaded, then the signature of the parameter, which is also a bag class, should be added to the overloading signature, right? __ signifies signature, and then we have this parameter signature. But as you can see, when I compare it to Java H tool, or if you use Java C-H, you see that it adds this _00024 to the signature of the method here, because this should be $bag, but $, is replaced by _0024. But then the same thing in the parameter signature. This should be $bag, right? And we said that $, should be replaced by _00024. But as you can see, the Java H tool, when I ran it, it didn't add this 00024. And apparently this seems to be a bug, because if I go to my test inner class, if you recall in test 2, we are creating this bag class in C++, and then I'm using the toString method, and then I implemented this print size for the bag class in C++, and this print size is this one, this instance method, and we don't need to specify the parameter signature because it doesn't take any parameter, and this one worked fine. So if I go to the C++, this is the print size that takes no parameters. So we compile this, it compiled fine. We copy and pasted this native library to Java, and then if I run test2, which creates the bag class, inner class, which is bag in C++, and sends it to Java. And then if I run this print size method, which is implemented in C++, this should work fine. So I'm running test2. Let's see. Yes. So the size is 32, and the size is set in C++ to be 32. I can also run the toString method to double check. Yes. So the bag size is 32. This is the toString method in the static inner class bag. And then I have this print size, which is a native method, and I implemented in C++. But once we try to implement this static method, print size, which is a static method, and it's overloaded. So in the header file of this bag, we get this signature Java _package _class, which is $bag, and the $, is replaced by _00024, and then the method name print size. But then because this is overloaded, we have to also specify the parameter signature, and the parameter signature is a bag class inside this person. So test22 / $bag. Now in this comment, the $, is replaced by a slash, right? But it should have been $. It's better to also keep it as $. But then the problem here is that the $, is replaced by _00024 here, but it's not here, and that's causing the problem. So if I go to my CPP, include this bag header, and then pretty much copy and paste the code that I had for the print size, the instance method, and use it for the print size of the overloaded one. This is a static method, so we get a J class, which is a bag class, person underscore bag. So this is a bag class, and the reason we get a J class reference because this print size is a static method inside this bag class, right? A static native. And then the J object is a bag object again, because we are sending the bag object. But then the problem here is that, okay, I can remove these two because I don't need to ask JVM to find the J class because I already have a reference to it. And this field ID, I know that this object is also of type bag class. So this J class is enough for me to get the field ID size, and the type of this size field is integer. So I get the field ID of the size, and then I invoke the getIn field on this actual object, which is of type bag, right? And this returns an integer, and then I print it. So this should work, but let's compile this. Compiles fine, it builds fine. Let's copy and paste the dynamic library and go back to our test inner class, and right now I'm invoking this static method print size on a bag instance, and this print size is inside this bag class. So let's run this, and it throws an unsatisfied link error. And in the previous lecture I left it as an exercise for you to try to figure out why this happens, because the code should work fine. And the problem is the bug that if we have a $sign and it's replaced by underscore 00024, it should also be replaced here. So right now in this $, it's only replaced by underscore, which is not correct. So the Java H tool should actually give us underscore 00024. This should happen. So the signature of the function, everywhere where we have the $sign, even if in the parameter signature, it should be replaced by underscore 00024. All right. And if I go back to my CPP and also replace it by underscore 00024, and if I compile again, it builds fine. And let's copy and paste the dynamic library to Java. And now let's try to run this static method print size, which is an overloaded method. It takes a parameter of type bag. Let's run this, and now it works fine. So that's more or less a bug in Java H tool. So if I run this again, the instance method, which is overloaded, works fine. The static method, which is also overloaded, works fine. And the problem that we had previously was that we were using an underscore here, which is wrong. That's why it couldn't find the actual signature of the method in C++. So wherever we have the $sign, it should always be replaced by underscore 00024. All right. So if I go back to my PowerPoint slides, on this slide I mentioned that in the method name $is replaced by underscore 00024. And then I mentioned that if it's in the parameter signature, $is replaced by underscore. But this is not correct. It's actually should be the same. $is always replaced by underscore 00024. In the comment, when in the comment that it specifies the signature, it says it's an L test22/person/bag semicolon. But this slash is actually the $sign, right? Because this bag is a static inner class. So the takeaway here is that in this case, it's more or less a bug in the Java H tool when it generates the header file, because if this inner class is the parameter of an overloaded method, so we have to specify its signature, and the signature also has this $sign, and this $sign is replaced by underscore 00024. All right, and this underscore 2 is just the semicolon. So L semicolon, any object signature starts with L and ends with semicolon, and semicolon is replaced by underscore 2. All right, but the $sign is always replaced by underscore 00024. So just keep that in mind, that if you use the Java H or Java C-H, you have to be careful about this bug in the header file that it generates. All right. So this is how we deal with inner classes. So there are two topics that we so far have looked at. One was how to instantiate, create inner classes in C++. For example, a static nested inner class and then a nested inner class which is not static, how to create them and send them to Java. And we said that in C++ we have to be careful about the nested classes that are not static, because their constructor in the bytecode, actually the first parameter is always reference to the instance of the outer class. All right. And then the next thing that we looked at was how to implement the native methods inside the inner classes in C++, and then in Java we can call them. And it could be a regular instance method in an inner class or a static method in an inner class. So we have looked at both of them. So there is a third type of inner classes which is called method local inner class. And the difference here is that the previous inner classes were inside the body of a class, but method local inner class, the name is pretty much explanatory, means it's inside the scope of a method. So that class, if we define it inside the scope of a method, does not exist outside the scope the method, right? And so the scope of definition is inside the scope of a method, and we cannot define it as a static class. It's not possible, because we cannot, remember, with a static inner class we can actually instantiate it directly using the new keyword. We just say outer class dot inner class, that's the type, and we can directly use it. So for example, if I go back to YouTube, let's close this header file and C++ file. So in test 1 here, I create basically, in order to instantiate a static inner class, I just directly use the new keyword, but the type is person.bag, right? But we could do another way by just directly importing the bag, right? Import basically person from test 22. And then I could just directly import the bag object, right? And here I could just say bag equals new bag. And this code, let's run test 1. This code should still work fine. Yes, bag size equals 5. So a static inner class is more or less independent of the outer class. The only difference here is that a static inner class can access any static field inside the outer class. But the way we instantiate it, it's pretty much similar to any other object. However, for the nested inner class, we said that we have to have an instance of the outer class first, and then use the .new operator on the instance of the outer class. All right. But if I have a method local, so I have created this test method local, and in the main method I have this static test1, and in the test1 I have this class called a student, and it's very simple. It just has a name and integer for age. The constructor takes the name and age and sets them, and I have a toString method that prints the information, and I have a native method, print info. So this is a native method inside this method local inner class. Method local inner class, and the scope of this method local inner class is limited to this method. So this class does not exist outside the scope of this method. But if you look what the compiler does, the compiler actually creates a separate class file for this student. Its signature, however, for inner classes, the signature was outer class $inner class. So this is similar, but the difference is that this is more or less like an anonymous class. If you are familiar with anonymous classes, we know that the anonymous class becomes outer class $1 or $2, $3, right? These are the class file names of the anonymous classes. So this method local inner class is also more or less similar to an anonymous class, but it has a name. So anonymous classes don't have a name, so the compiler uses outer class $1. But because this method local class has a name, the compiler adds $1, but it also adds basically the name of the method local inner class. So if I go to the Java perspective, look at the bytecode of this class. Let's zoom in. It's the package / the outer class test method local. This is the outer class, and then it adds the $1, which is typically used for anonymous inner classes. But then because this inner class actually has a name, it also adds the name, right? So the difference here between an inner class and a method local inner class is that for an inner class we have outer class dollar inner class. For method local, it's a little bit similar to an anonymous class. So it's outer class $1 inner class name, right? So it's not just dollar, it's $1. And again, you can already know what happens in C++ in the method signature. Dollar is replaced by underscore 00024, but 1 is just 1 there. All right. So if you have outer class $1 student, the inner class, then in the method description we get outer class dollar becomes underscore 0024, the 1 is still there, and then we have the inner method local inner class, right? So this is more or less the signature if we want to create a header file for this native method inside this method local inner class. All right, so back to PowerPoint. So we cannot have a static identifier on this class. It cannot be a static inner class, and the class path description is outer class $1 inner class method local inner class. So it's not only dollar, but there is a 1 added to give it more or less a sense of the fact that this is similar to an anonymous inner class. But anonymous inner classes don't have a name. This class has a name, so it's $1 and then the class name, right? And then dollar is replaced by underscore 00024, and then we have the 1 there. So this is the description when we generate the header file. So the other thing is that for inner classes, we saw that the constructor actually keeps a reference to the outer class. But here, these classes, this method local inner class is not static. But then again, the constructor doesn't keep a reference to the outer class, because this is the scope of the class itself is inside the scope of the method. So there is no reference to the outer class. So what we can do here, let's see. Let's see if we have an integer 2 inside the outer class. Can we have a reference to the instance fields of the outer class? And the answer is no. Cannot make a, so basically this is a static method, that's why we cannot. So let's make this a static int, so we can actually get a reference to the fields of the outer class, but because this is a static method, I can only access the static fields. All right, but the thing here is that we cannot really instantiate these method local classes outside the scope of this method, because these classes cannot be static. So if I add a static modifier, it complains and it tells me you can only use abstract or final on this method local inner class as the identifier. So I cannot have it public because this is not available outside the scope of this method. And I cannot even do it private because it doesn't make sense. You cannot use it outside the scope of this method anyways, so it doesn't matter if it's private. I can only define it as final or basically abstract, one of these two. All right, and obviously a class cannot be both final and abstract, but the only legal modifiers for the method local inner class is either final or abstract. So compiler generates a separate class file for each inner class, even if it's a local inner class. So if I go back to Eclipse, you see now I'm instantiating a student 1, Bob21. I call the toString method on it, but I also look at the student.class, the class meta information of this method local inner class. So if I run this, it tells me the class is test22, which is the package dot outer class test method local $1. So this $1, not only dollar but 1, and then the student, which means this student is not an inner class. It's more or less like an anonymous inner class, but it's an anonymous class that actually has a name, a student. So it gets $1 and then the name of the class. If I go and look at the binary, so properties, let's go, Let's go to the binary folder of this project, test22, and as you can see, it's the outer class $1 inner class. This is a method local inner class. So $1 again signifies it's more or less an anonymous class, but then it actually has a name, a student. Unlike the previous inner classes, bag and book, they were inner class, so get a $sign and then the name of the class. Here we get a $1. All right. If I have two method local inner classes, they still get $1. So a student 2, and then if I look at the student 2 class, it still gets $1. It doesn't get $2. Unlike anonymous inner classes that each one that we create, it gets $1 or $2, etc. So let's run this, and as you can see, it still gets this $1 and then the name of the class, student and student 2. So if I look at the binary file, and now I have two .class files. One is $1 student, $1 student 2. So each method local inner class gets compiled to a separate class file, and then it gets a $1 in its class path description. So the $1 is always there. It never goes to $2, etc. for method local inner classes. So obviously the next question that we want to answer is that how do we create a header file? So if my method local inner class has a native method, in this case print info, so how do I create a header file? So if I go to the C++ perspective and click on this test method local, and then run my Java H tool or Java C-H, what happens? So it creates a test22 underscore test method local. So it creates a header file for the outer class, but that's empty because I did not put any native method inside this class. I put it inside this method local inner class. However, if you recall, for proper inner classes, for example, in this person class, we had this inner class book and bag, and we saw that if we run the Java H tool on the outer class, it automatically generates the header files for the native methods of the inner classes as well. But for the case of method local inner class, the Java H tool or Java C-H, they don't use they don't basically create header files for the native methods of this inner class when we run them on the outer class, because again the scope of this class is limited to this method itself. So what we need to do, we need to manually invoke the Java H tool on the class file of this inner class. So I have to manually tell the Java H to run it on this method local inner class, this class file. Remember, Java H runs on the class file, not the Java file. All right. So how do we do that? So what I want to do, let's delete this empty test22 underscore test method local, and let's go to basically PowerPoint. So method local inner classes can in fact have native methods, and if we use Java H-JNI or Java C-H on the outer class, they cannot generate header files for the method local inner classes. All right, they do not generate header files. But then what we can do, we can manually tell the Java H to run on the class file that was generated for this method local inner class. So what I'm going to do, I'm going to go to my external tool configuration, click on my Java H tool here and duplicate it. And in this one, I'm not going to say Java type name. And remember, this is the outer class. This is the outer class. What I'm going to do, I'm going to let's close this. Let's run this to get the, so I'm going to copy and paste this class description of this method local inner class, and then going to external tool in this Java H number 1, which is a duplicate one, and then I'm going to manually tell it to run on test22 dot outer class $1 method local inner class. All right, so I'm manually telling the Java H tool to run on this class file. Remember, Java H runs on the class file. So apply and now run. So there is no error. Let's see what happens in our header file. As you can see, this student.h was generated, and it has basically the description of this method local inner class. And as you can see, it has the $sign replacement, which is underscore 00024, and then the 1. So let's see what we expect here. So if I go back here, the signature of this native method inside this method local inner class should be Java underscore package name, which is test22 underscore class name. The class name is outer class test method local $1 inner class, which is a student, all right, underscore method name print info. And then we said that dollar is replaced by underscore 00024. So this dollar becomes underscore 00024. But this 1 is still remains, right? It's still there. So underscore 00024 1. And that's a very cryptic syntax or signature, but that's how the Java Edge generates that. And note that when we manually run it on the inner class, it doesn't add the package name underscore class name. It's just the class name, a student. All right. So we have this. I'm going to go to the basically src and create a new C++ source file and call it method local inner class .cpp. And the very first thing that we do, we include the header file, include .header, and then a student.h, and then the copy and paste this function prototype. And then the first parameter is a pointer to our environment, which is JVM and JObject. So remember, this method local inner class, this print info is an instance method, right? Print info is an instance method. So basically we get a reference to a JObject, which is the calling object. Let's call this a student obj. And oh, sorry, this is the header file. So we should not touch the header file. So in the implementation, this is the student underscore obj. This is an instance of the student object. And print info, what I want is, let's say we just want to print the name and age, right? So what I want to do is get a hold of the J class, which has the meta information. So a student class, and I already have a reference to this basically object. So I'm just asking JVM get object class, and then student object. And then what I want to get the fields, because name and age are fields. So J field ID, basically name ID is JVM get field ID. And then a student class, the name is name, and then the signature is a Java string, right? So signature L semicolon, because it's a Java object. So Java /lang/ string. And I also want to get the basically age, the field. So JVM get field ID, and then a student class, the name is age, and the signature is integer. And now I want to actually call them JVM get int field, and then a student object, and then age ID, and this returns a int or jint age, right? Get int field returns a jint. And then JVM for the string, because it's an object, so get object field, which means we are getting a field which is a Java object. So a student object, the field ID is name ID. And then this returns a J object, and I'm going to cast it to J string. And so J string name. All right. And then this is a Java object. So what I need to do, I want to actually get the C++ character. So const char pointer name array or name chars is JVM get a string utf-chars, and then the pointer to the string, JString is name, is copy, and then because this puts the array on the native heap, we have to eventually call the JVM to release a string utf-chars, and then the pointer is JString, and the actual array is name array. And then I'm going to do a printf on basically name %a says age is %d, and then this the name chars, and then age. All right, so this is how I implemented this instance method, this native method inside this method local inner class. And again, the implementation is very similar to what we've seen so far. The only difference here is that the signature of the method, it's outer class $1 inner class, and then the method name, and then the dollar is replaced by underscore 00024, and then the 1 is still there, 1. All right, so let's compile this. It compiles fine. Let's copy and paste the dynamic library to Java and go back here. So in test1, I'm creating a student class, a student object, a student1, and I do a toString and then print its class file, which is fine. Let's also load our dynamic library, system.load library, and then native underscore C. And then now I'm going to invoke this print info, which is a instance method, and it's native. So let's see if this works. And yes, it works. Bob's age is 21. All right. So what if this method was overloaded? So let's also add the public static native void print info, but here we provide a student object, a student. All right. So it says that you are not allowed to define any static method inside a method local inner class, because we won't ever be able to call access this method, access this class outside this method, right? So it's complaining that a static method can, so the method print info cannot be declared static. So let's just basically convert it back to an instance, but with a overloaded parameter of type student itself. All right, now I can run my Java H #1, which still creates the header file, and it updates the header file again. So cannot determine the signature for a student. So apparently now there is a problem because it cannot deal with overloaded methods. So I'm going to run this one more time. All right, and then so this student test 22. So the way we are going to access it with something like this, but it's so if I go to the bytecode, Java perspective bytecode, it's empty. So this is probably an illegal way of doing it, because this student, if you look at the signature, is test 22, and then the outer class dot method name dot class, right? It's something like this. So let's see, test 22 dot outer class dot basically test 1. This is the method name, and then a student, but this never works. So I guess this is not a way to overload with an and it doesn't make sense to overload the method with the type of the student itself, because we can never have a static method inside this. But if I write something like a string name, let's see if we can run the Java H again. So let's run my Java H1 tool, and now it works fine. If I look at the header file of the student, we do have overloaded, but again and it works fine, but we don't run into the bug that we had with the static inner class, because it doesn't, for the method local inner class, it doesn't allow us to pass in a reference to the student itself. All right, so this is overloaded underscore, and then the method parameter signature. And again, in both of these cases, we have this $1 and dollar is replaced by underscore 00024. All right, so I'm going to remove this overload, and then run the Java Edge tool again manually, and then it's going to update this for me. So the key takeaway here is that the way we configure this external tool, Java Edge, it invokes on the Java type name, right? And then this Java type name is the name of the class file associated with whatever we select here in this tree. And this in this case, test method local is the outer class. But when the Java Edge runs, it doesn't actually see this inner class because it's enclosed inside the scope of this method. So the way we have to generate a header file for the native methods inside this method local inner class is to manually configure a Java Edge tool or Java C-Edge tool and give it the class path description of this method local inner class, which is package.outerClass $1. So don't forget 1. And then the inner class name. All right, and then it is able to create the header file, and once we have the header file, we can add an implementation, and then don't forget that dollar is replaced by underscore 00024, and then the 1 is still there. And then after that, we can just compile and then add the native library to Java, and then we are able to actually call the native method inside the method local inner class. But this is a very rare situation. I personally have never needed to actually add a native method to method local inner class, but it's you can do it if you want to. The way you generate the header file is a little bit different, but it's possible. And as you can see, we are successfully calling this native method, and it prints the name and age. All right, so back to PowerPoint. To summarize, method local inner classes, we cannot declare them as public, private, or static because their scope is inside the scope of the method. The only legal access modifiers are abstract and final. And then if I have this test1 method and then create an inner class student and add a native method, I have to because the compiler creates a separate class file for any class, whether it's an inner class, a static inner class, method local inner class, doesn't matter. But the class path description of the method local inner class has $1, so it's outer class, $1 inner class. For typical inner classes, we only have $, outer $, inner. For method local, we have $1, which kind of signifies this is more or less an anonymous class. We don't have access to it anywhere in the class. We only have access to it inside the method. So it's more or less like an anonymous class, but it's an anonymous class that actually has a name, because a typical anonymous class doesn't have a name. And as you can see, the $sign is replaced by underscore 00024. For regular inner classes, for method local, it's $1, so the signature is underscore 00024, and we have this additional 1, all right, between the outer class and then the inner class. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.